Thank you very much for introducing me. All these nice work about my background and my research interests. I hope that I am as good as what Eden described me. So, but I have to confess to you that I am still learning. Since day one I joined HKUST, I have been very interested in doing something practical that can have some impact to our industry and also our society. So I think building is something which can fall into this dimension because it covers a lot of multidisciplinary area. I'm myself a mechanical engineer, so of course I will focus more on the area that I'm good at. But because I also serve as the Associate Dean of Engineering in the last 2 years, I also learned something from my colleagues in engineering school. So I expand my interest to some other areas, not just in mechanical engineering. I'm not so sure about whether I can cover anything in the social science area, which is also a very important area that we should definitely look at, especially when you look at smart building or green building. I think we talk about the occupants, and you have to look into issues like human behavior, how you are going to understand the human behavior, their living pattern, so as to cut down energy consumption or to look at new business opportunities or new research opportunities that can benefit both the university and our commercial and industrial stakeholders. So this is the topic today, and by looking at this topic, probably we have the feeling that building is not just about providing a shelter for protection, which is a very old concept. Since our civilization move on, we have been looking into the different functions of building. I'm pretty sure that our architect friends, they have their very different perception of what a building should be. And obviously, a building may have its life form, and we talk about integration of building and the occupants who work, live, and enjoy their life inside the building. And actually, many buildings serve as landmark for the cities and for the countries itself. When we look at this concept of smart building, actually, you look at textbooks or historical development. As far as I understand, people started to use the term smart building as early as like 30 or 35 years ago. At that time, we talked about some kinds of technology. Of course, from today's perspective, you may not feel that they are very advanced. We talk about like building control system. We talk about some elevation and transportation system, air conditioning or advanced air conditioning system. So we call our building smart building since day one, many years ago. And gradually we move on to develop many other new terminologies, including intelligent building. This is why you look at HKUST, we also have our Master of Science program in mechanical engineering, looking into intelligent building technology and management. If you look at the smart building concept, we are actually looking at a number of very interesting issues, like how you enhance management and occupant functions, how we integrate different building technology systems together. We are also looking at construction and operational efficiency. And in recent years, we also talk about green building development. I know that we have our chairman of Green Building Council in Hong Kong here today. In fact, I'm also one of the expert panel members in Green Building Council. In recent months, you actually see many activities coming up from Hong Kong Green Building Council, moving into that direction. We focus a lot on many interdisciplinary issues, including how we make use of our resources in a very efficient way, how we look at all these design and operation issues from a life cycle point of view. But I think the key issue is a green building is a building that can keep the lowest impact to the environment. And this is why you look at international standards like LEEDs, they talk about leadership in energy and environmental design. They focus a lot on how to bring all these different kinds of green elements into building design. And HKUST has been working on this smart green building concept recently. We are building up a big program trying to integrate both smart building concept and green building concept together in our research. I'm serving as an associate editor of the journal, and recently I put down some of my thinking about smart green building into an editorial, talking about my view of smart green building of tomorrow. I try to put down some of these key elements that I think important into our discussion. I think we are talking about a low energy consumption, which is very important because we don't want to spend too much of our precious resources into operating the buildings. We are talking about how to maintain a comfortable indoor environment to the occupants. This is also very important because we do not want to sacrifice the comfort level of our occupants. And of course, this is related to intelligent indoor environmental control. We also talk about a smart energy flow purchase concept because if we are using more and more renewable form of energy, even though we have not reached this yet, but in the future, maybe we are talking about the building is producing some surplus energy that can be, that can be sold to other buildings. Some countries have been doing that, but not yet in Hong Kong. But we are thinking that perhaps in the future we might be moving in that direction, or in some small community we may be moving in that direction. Recycling, which is about how you can cut down the waste production and then convert some of these waste into energy or other useful form of resources. And then we talk about excellent communication with the users and the occupant, which is also very important. And then I can put all these into this perception picture of a smart green building. We have many people working on renewable energy generation. We have people looking at energy storage management issue. I'm serving as a member in the Research Grant Council. We have a meeting in the last 2 days. I look at the proposal. Basically, you will see that many new proposals submitted to the Research Grant Council, in fact, fall into these two major topics: renewable energy generation and also energy storage, indicating the importance of this topic in smart green building development. And then we also have smart monitoring and waste treatment, which is also a key issue that we are dealing with. And at the end, I'd like to highlight this important concept, which is intelligent living, because we want to put new things into a building. At the same time, in fact, we are creating some kinds of new style of living. Like nowadays, everybody has our smartphone or something like that. In fact, if you look at the use of the technology, we are actually changing our lifestyle. Same in building, because we put many of these new elements into our building. We are in fact changing our style of living. That actually creates a lot of new business opportunity for many industrial stakeholder or commercial stakeholder. My view is that this smart building or smart green building concept can actually move to a number of new business initiatives that can benefit not just the user, but also the business stakeholders who are involved in it. And at the same time, you can also build up your brand value. So I try to list down some of the research projects that we are currently working on in the School of Engineering and HKUST. It can be divided into a number of areas, including renewable energy generation, air conditioning, and cooling system. Because if you look at building usage, a large amount of the energy is actually used in the cooling aspect. So cooling and air conditioning is playing a very important role. Building materials, of course, is also building a very important role, and it also affects the overall energy consumption of the building. Lighting system, I know that some of you are in the lighting business, so I think this is also one area that some of our researchers at HKUST are working on. And of course, you cannot stay away from control. We have to rely on smart control to take care of the like ventilation issue, lighting issue, etc. in building. So to be more specific, I'd like to talk about a number of issues, a number of projects that we are already having results, and we'll see if we can move further ahead and work together with some of the commercial and industrial stakeholders here, including integrated cooling, heating and power generation system, absorption cooling system. And we are also developing new kinds of heat transfer fluid called Nanofluid to enhance heat transfer performance of some heat exchanger and building cooling facility. Thermal storage, small scale wind turbines for use in buildings. And also I will touch upon a little bit on a concept of waste to energy using plasma gasification technology. And then if you have time, we can also go into other things like wireless system architecture, MEMS-based flow sensor for energy efficient building usage, etc. This is the concept that I have been promoting in recent years. We are talking about the use of solar energy to generate electricity. A lot of researchers are working in that direction. But solar energy is not just to be used as a conversion to electricity. You can also use solar energy to do cooling. And sometimes you don't have enough solar energy, so you may need to integrate an energy storage system into your overall design so that you can save some of this energy and combine with electricity generation from other sources. So in winter, we are talking about heating. In summer, we are talking about cooling, and some of the energy will be used as electricity to run the lighting system. In Hong Kong or in many buildings in the world, in the air conditioning system design, we usually integrate both what we call sensible cooling and latent cooling together. Sensible cooling means the temperature difference. When you go into a room, you feel very hot. You want to lower down the temperature. Okay, this is what we call sensible cooling. But there's another equally important part, which is what we call latent cooling, which is about relative humidity in the air. Most of the time in the building design, we cool the air to a substantially low temperature. The reason is that we want to condense the water out. But after you do the condensation, usually the water will be out, but the air will be too cold. You have to do a reheating, but this is talking about using extra energy. This is why many buildings do not do that. So this is why you either have a very humid indoor environment, or you have your indoor environment too cold. Some people criticize that Hong Kong is one of the many places in the world, in Asia Pacific region, that has very, very low temperature. In summer, people feel freeze when they step into an office in Hong Kong because the temperature is just too low. So decoupling this sensible cooling and latent cooling can be a really good concept, and it can be achieved by using some advanced adsorption material that we developed in our university. So I'm going to talk more about the absorption cooling system, and also you can integrate it with an absorption wheel to do dehumidification in order to cut down the energy consumption. The basic concept of an absorption cooling system is that instead of using a compressor in our air conditioning system, we instead use a absorber and desorber system. So when we have, we don't have refrigerant inside, the so-called refrigerant is simply the water. And under low pressure, the water will absorb the heat and evaporate, okay? And then it will go to the absorber, and then it will be absorbed by the absorber. And then you use waste heat, or you use solar energy to desorb the water away from the absorber, so then you complete the thermodynamics cycle. By doing that, we can get rid of the very energy causing compression system, and you can also reduce the noise issue. So this is one thing that we are currently working on. But the research bottleneck is the absorbent material, because you have to ensure that the absorbent material can have very high water absorption capability, number one. Number two, you also need to ensure that it has very good heat transfer performance. Otherwise, you will not be able to get cooling fast enough, and your system will also be very bulky. So we spent a lot of time developing different types of advanced composite material so that we can enhance our heat transfer. We can also increase the water uptake capability so that we can make the system as compact as possible. Now we have a lot of so-called experimental prototypes ready in our lab because of the funding supported by both Innovation and Technology Fund and also by our government through the General Research Fund Scheme. I think this is a very mature project that can move one step up if we are able to work together with a commercial partner. Now we have experimental prototypes that are running quite well. In order to move to real commercialization, I believe that the support from the industrial stakeholder will be very, very crucial. The key advantage is that you can make use of solar energy and waste heat in order to replace the compressor that we use in traditional air conditioning systems. So we can also get rid of the use of toxic volatile organic compounds that we usually use as a refrigerant in our traditional cooling system. And even in some advanced liquid absorbent system, we use toxic liquid that can also cause corrosion issues to the system. But if we use a solid absorbent, then we can avoid use of all these corrosive chemicals and further enhance the life of the refrigeration and cooling system. So we have been doing quite well. In fact, some of my graduate students, they joined the HKUST $1 million entrepreneurship scheme. We got the second prize. And since then, we have been interviewed, not me, my students have been interviewed by many newspapers, and also they even show up on radio to talk about their technology. This is why I think this is quite mature. Perhaps we can move one step up. Other kinds of research that my group is now working very hard on is to further enhance the heat transfer feature of some air conditioning system in a smart building. So we develop different kinds of nano fluid. The idea is not difficult. You basically put nanoparticles, very small one, usually smaller than 0.1 micron. You cannot see them at all. So you put them into some base fluid that can be water. All right. But there are a lot of technical challenge because these small nanoparticles, they will stick with each other. After you run it for a certain period of time. So how you ensure that they don't stick together depends on a lot of research. You may need to add some other chemicals into the fluid. So we are working on that. We are noticing that we can enhance the heat transfer performance by more than 10 to 20%. So this is one area that we are able to secure some funding recently to look at the heat transfer side. We also supervise a number of students to work on a few design projects. Recently, we noticed that by using these nano fluid, we can further enhance our cooling system performance by more than 20%. Together with some improvement on the evaporation side. The evaporator is also important because it is the device that absorbs the heat from the building and dissipate the heat to outside using another system. So we are also developing some what we call capillary assisted evaporator. This is to further enhance the performance of the cooling system. So all these will actually fall into one single theme, which is to make major breakthrough to the existing cooling and refrigeration industry. Because if you look at the total energy consumption in building, something like 50% of the energy in Hong Kong goes to building, and some 40% goes to air conditioning system. So we talk about something like 20% of the total energy consumption. So if we can do something in the cooling side, we can create a new industry. We can also change the overall landscape of the picture by lowering down the energy consumption and cutting down the impact to the environment. Thermal storage is, of course, a very interesting topic, and it has a lot of practical values. There are many phase change material that we can use to do thermal storage. Phase change materials means the material that can absorb heat during daytime, and they will change phase from solid phase to liquid phase. By changing phase, they absorb a large amount of energy, which is much more than simply changing the temperature. So you gradually release the energy out during evening time, so your building will not, occupants inside the building will not feel too hot, and you can cut down the energy consumption. There are many phase change material going on in the market under research, and we are looking at organic phase change material like paraffin versus. There are many things that we need to do in order to enhance the performance, and we also need to add different kinds of additives into our phase change material in order to maintain the performance. So this requires the collaboration with many material scientists. So this is one basic research area that now triggers a lot of interest in our research group. Small-scale wind turbine is one project that we are now investing money to work on in our Namsa Fokingdong Graduate School. We have a building energy research center there. Because if you install wind turbines in building, it is limited by the wind velocity. So most of the wind turbines that you see in the market, they can capture wind energy if the velocity is about 3 meters per second. But in many city environment, the velocity cannot reach 3 meters per second. So we need to find a way to do that. And the existing wind turbine usually have a relatively low power efficiency. They also requiring current charging technology, which could damage the battery. So these are the two major issues that we are dealing with. And we are now integrating a supercapacitor concept into our small-scale wind turbine. By doing that, we can actually capture the low wind velocity at 2 meters per second. This will enhance the application to smart building demonstration. And we can also make use of pulse charging technology to lower down the damage to our overall system. And at the same time, we are putting a maximum power point tracking device so that we can maintain a maximum charging efficiency to the batteries. This is done by adjusting the charging current, such as the power loss can be minimized. So this is a very interesting project that we are now pushing really hard on. We really think that if some companies are interested, we can work together and then we can move further into commercialization. This is a very preliminary idea. A few months ago, we have been approached by a North American, very big company in the US. They are very interested in converting solid waste into energy, right? But this is not like incineration, because in incineration, you actually supply oxygen to react with the waste, and then you will come up with temperature like 1,000 something degrees Celsius. But in plasma gasification, you make use of a plasma up to produce a much higher temperature. It can go to like several thousand degrees Celsius. And at such a high temperature, the reaction is not like you have oxygen reacting with the solid waste, but instead the solid waste is integrated into different kinds of very useful gases, including hydrogen and carbon monoxide. So we have been thinking about building a pilot plant in our Building Energy Research Center in Namsa, trying to work with a company. And the overall idea is how to convert waste to energy in a very efficient way. And by producing hydrogen, we can also make use of the hydrogen to support other kinds of energy devices like fuel cell, so that you can enhance the application of the waste to energy system. So now we're doing a lot of preliminary computational work so that we can optimize the design. But I think this is one area that may have some potential in the future, especially Hong Kong is now looking for different ways to lower down the waste generation. And I'm not sure if I still have time, so I will try to go into other area that I may not be too familiar with. We talk about smart control and ventilation. I think wireless infrastructure is a very convenient thing that we can do in buildings. By doing that, you don't need to think of where to locate the sensor. Okay, you can simply locate the sensor in the best location to capture the environmental parameter. So our EC, Electronic and Computer Engineering faculty are actually working together with us in looking into this wireless infrastructure and how to make effective use of wireless infrastructure in smart green building design and operation. This is another project using complementary metal oxide semiconductor and in micro electromechanical systems. We build flow sensors that can be used to collect environmental data from indoor environment. There can be temperature, there can be relative humidity, there can be concentration of different indoor contaminants. So by collecting these parameters, you can actually go back to your building management system and adjust the right amount of airflow or ventilation rate to do the comfort design that you are aiming at. Why we are looking at MEMS device? Because by making MEMS device, you can make the sensor very small. At the same time, you can do a batch manufacturing and cut down the cost quite substantially. So I think my colleague in mechanical engineering, with a YTV, is now working on that. He is recently going to get a funding from one of the public utility company in Hong Kong, try to develop a MEMS-based flow sensor to do energy monitoring in buildings. So this is a very exciting project that will have a lot of impact to the smart green building development and operation. Personalized air supply system is something that we are quite interested in looking into, because most of the building design in the world, including Hong Kong, relies on supplying air from the ceiling level, and then you have a so-called perfectly mixed environment inside. This is good for thermal comfort, but from energy consumption point of view, or from a indoor air quality point of view, you may not be very effectively diluting the contaminant. So one way to do it is we still keep the maybe 50% of the air supplied through the central perfectly mixed system, but we divert the other 50% to a separate system called personalized air supply system. So each individual or each individual group of occupants can get some fresh air directly to their breathing zone. This is one approach that can help to ensure good indoor air quality. At the same time, you can lower down the total energy consumption. But this requires a lot of support from instrumentation and sensors. So this is why this is a good project to integrate with the application of MEMS-based smart sensor to collect environmental data. And then the data can be used to monitor the building management system, so that they can have the, they can make decision on how much air goes to the individual breathing zone, how much air goes to the, centralized region. So this is one research direction that we are also moving forward. LED lighting system is, of course, we have many researchers at HKUST, both in material science group and also in our mechanical engineering, electronic and computer engineering department, working on LED device development. But we are also spending effort in doing thermal management, because if the temperature is too high, meaning that you cannot dissipate the heat properly, then the efficiency of the LED devices will also go down. This is why we are spending equally amount of effort in understanding how to design efficient system to dissipate the heat away. Our mechanical engineering faculty members are supervising a number of projects in this area using nano structure to enhance the surface heat transfer characteristic.
So our civil engineering faculties are very keen on developing new kinds of material for integrating into a wall panel. This is to enhance good thermal insulation. They develop different kinds of fiber reinforced cementitious composite material. And in that, the group have also recently submitted a theme-based research proposal that has been shortlisted by LGC. They will have an interview, I think, tomorrow or the day after tomorrow. We are moving into this direction and try to find industrial partner also to commercialize some of these new building materials in order to cut down energy consumption in buildings. So the last slide I'd like to share with you is an overall conclusion. The big picture is that by working in this area, we are not just talking about one or two areas. We are actually talking about a very diversified interests covering energy generation, smart monitoring, energy recycling, environmental issue, gas or energy metering, things like that. So this is a major research initiative at HKUST at the current moment. We have very strong research track record both from LGC and also from Innovation Technology Commission. We have been working with a number of industrial stakeholders to commercialize some of the devices. And I think we still have a lot of room for big research collaboration with other commercial and industrial partners. This is to make sure that our work is not only working in the lab. I think from working in the lab to working in the commercial world and how to make it a business that can benefit more people is a big gap. That certainly requires support, not just from HKUST faculty or our management, but we need support from actually all of you. So my view is that perhaps we can think of setting up something medium to big scale on this smart green building initiative, and then we can continue working in the area. But I think the most important thing is that we are learning, and then we hope that we can hear more comments from more of you who certainly know more than our university faculty members. Thank you very much.